Okay, guys, I think we're going to start. Good morning. You don't want to move to the front? You don't want to say good morning? Come on. I have a laser in my hand. I can point it at you. Good morning.
Good morning.
Hey, there you go. So this is the CCDE session, whatever number, 802, 8001, and 8002. The first question, who signed up for both sessions? Wow. Good. Don't pay attention to him. Okay. We don't know why. This is a 4-hour session. We don't know why in the schedule shows up as session 1 and session 2. It should really be one session instead of 2. So we know, and we already heard some people that signed up only for the first part, or even worse, only for the second part. We'll figure it out. So for this to work, we need all of you to give us a 5 in everything, so that when the other guys who get screwed because they only showed up for the second part, and they give us all 1s, it balances out. Is that a deal? Yes? Nothing. No good morning, no thing, nothing.
It's almost like we went to the party last night.
Did you go to the party last night? Didn't go to the... Yes? Someone did. You did. Cool. Okay, so my name is Alvaro, and I'm an engineer at Cisco. That's Bruce over there, and Yusuf over here. So we're going to, between the three of us, go through the 4 hours. When you get the slides, and I'm assuming you're going to get them at some point, you'll notice that there's a lot more stuff in the slides. We do this in the US, and they give us 8 hours there. Here, they gave us 4. And as I said, some of you are only going to get 2, and we'll figure that out. But as you look at the slides, there's a lot more information in there. So you can go look at the details and everything else. One thing that I want to make sure that all of you understand is this is not a talk about how do you pass the test. And when you walk out of here, you might not pass the test anyways. But the objective is for you to know why we're doing this test and what are the things in the test that you need to know. And we're going to go over some examples and things like that. But in reality, this is not how to pass a test. Who's here to learn how to pass the test? Good. Okay. Great. Okay, so we're going to talk about this that's listed up there. We're going to talk about what is the CCDE, what are some of the topics, what are the drivers and domains about design that we're looking at or thinking about as we build the test itself, so that you can start thinking about the same way we think. Mostly me. They don't think like they do. We're going to go into a technologies overview. Now, there's one slide in there that we say, what do you have to know? And in the one slide, it says pretty much everything, right? So when we go to the technologies overview, we're going to talk about some technologies. This is not a class for you to learn about all the technologies. Because as I said, you need to know everything. So we can't possibly go into everything, so we're going to go into some examples and talk about, from a design point of view, what things you might want to consider about this technology or that technology. And again, do some examples and say, this technology normally sucks, but in this scenario, it may be the right answer to design a network that way. In other scenarios, it's not the right answer, but for you to start thinking, as I said, like we think. And then we're going to spend quite a bit of time on actual examples. Examples for both the written and the practical test. The practical, as you may already know, is a scenario-based test. So that means that all the questions are related to some scenario. So when we go through this to the practical examples, we're going to go through a scenario, which means we have to go through the whole scenario. We can't just skip some questions and land in the middle because the scenario won't make sense. So we will spend quite a bit of time talking about that. If you have any questions, just ask at any point during the break. Later, we can anyone can talk to you about any of this. So when we talk about, or when we think about what is the CCDE, we like to look at it from different points of views. From the point of view of the candidate, from the point of view of the industry, the business value, and how does it fit within our other certifications. So that when we position a new certification, or still relatively new certification like this one, we know why we're doing this. What hole are we filling? How does it benefit the candidate? How does it fit with all the other certifications, et cetera? So what we see from an industry point of view is we see that, of course, networking and what we do in networking has been changing and maybe evolving. We see a lot of people specializing in different things. And so people have moved from normal just operation of the network. 20 years ago when the internet and everything was starting, or maybe 25 or more, we were worried about just getting the network to work. Now that everything is mission critical, now we worry a lot more, and this has been happening, of course, for the last 10 or 15 years. We spend more time on the design of the network. We spend more time worrying about it actually working and not having to reload it at 3 o'clock in the afternoon, right? So we see people specializing quite a bit, specializing in technologies like voice or video or firewalls or whatever, or in things that we at Cisco call places in the network, the data center or the edge or things like that. But what we notice about that is that we seem to have lost the roots of the network, meaning the infrastructure of the network. So it's great that we know a lot of voice, but that voice has to run over an infrastructure. It has to run over a bunch of routers and switches and do things and get to the destination. When we think about the cloud, yeah, it's great. There's a cloud over there. But who cares if the cloud is there, if the infrastructure can't take you to the cloud with the quality of service or the security or redundancy or anything else that you want your infrastructure to do. So in many cases, we seem to have sort of forgotten the fact that we have that infrastructure that we want to push forward. And we do see at Cisco, when we support our customers, that many think that the infrastructure just works or that it's magic. And we hear people, including us sometimes, talking about in the data center, do a full mesh of tunnels between the hypervisors, and then everything works. Sure, everything works, as long as the infrastructure under it works. So the focus of this is not on specific technologies or specific trends or fads or anything that you want to think about, but it is on the infrastructure of the network. How do I take requirements for new applications, for new innovations or new trends maybe, and design a network that is going to look at that end-to-end big picture of what the network is supposed to do versus just focusing on the edge or on the campus or the data center or just going to put everything in the cloud, right? We need to go back to the roots of networking and look at that big picture and at the fact that we need the infrastructure to support all these different things. We want someone, the CCDE, to be at a higher business level, meaning this person, as it says there, we want them to horizontally interact with middle to higher level management in the company, meaning you now understand not just how SPF works and why you want to put areas in there, but you can talk about the impact to the business of doing that. Or maybe understand that if the business, for whatever reason, didn't decide to do something that you recommended, what is the impact? What happens from a design point of view as a result of business decisions, because there's no budget, because there's no people, because they can't train you on the new technology, because whatever, and you were forced to select something. And now what is the impact to the specific business that you're in, right? Not just in general, oh, now you have to put more boxes or less boxes so you can't scale as much, but understanding what would be the impact to the business model of someone. Let's say you have a bank or something and you can't afford to buy, encryption or firewalls or things like that. Well, security is probably a really good thing in a bank. It's going to affect the business of the bank. So you want to be able to understand those trade-offs. Why you want to put technology to mix and match with the actual business goals. From a certification point of view, right? I said that we want to make sure that the certification fits somewhere with the other things that we have. So traditionally, we've looked at some type of continuum here between implementation and design, where things like CCIE, we look at it as implementation. You're going to go configure, troubleshoot, deploy the network. And on the other hand, over there, oops, we have the design side of the network, right? And of course, before the CCD, we had that hole up there that on the design side, and the other axis here is between tactical and strategic, right? So the assumption here is that if you look at CCIE, for example, the guy here with a CCNA has specific abilities that will help him in a more tactical way operate, troubleshoot, configure the network. Where the CCIE not only should be wider, but has probably more strategic impact in the network itself. And now can look at other things beyond just configuring one box, for example. But how does the configuration or the implementation in one area or one domain or whatever may actually help. So the CCD sort of fits up here, whereas definitely a strategic play, because we already had the CCDA and CCDP, so it's strategic in par with the CCIE, and it's of course on the design side. So I showed you before we had that sort of hole in there, where we thought we weren't certifying people at that high design level with the other certifications. So that's where it sort of fits. So there are several things that you want to look at, right? From the technology point of view, how do I don't know, add services or add new technology? How do I measure network? How do I add or change security? What type of security do I need in my network, for example? Technical considerations, but also business considerations at the same time, because I need to know and understand that when I'm designing a network, I'm not just, in real life especially, just saying, oh, here's a network design, go do it. In networks, we are in a state today, and we always want to get somewhere else. And so a part of that design process is how to get from here to there. What are going to be the required steps to move to transition my network? What is going to be not just the steps of I do this first and then that second? What is going to be the impact to the business? Are there hurdles in the business that maybe I can't get everything at the same time? Maybe I need to do it regionally. Maybe I have to go layer by layer. Different hurdles that you may have in terms of people or budget that may affect how the design ends up being, or how I get to that design, how I get to that point. So in many places in the test, we're going to ask you things like that. Okay, it's great. You did the design. Now how did you get there from this stage? And the answer obviously is not, well, we're going to just turn the equipment off, reconfigure it, and turn it back on. Right? That doesn't work. We need to move and still operate the business and still do whatever the business is going to be doing. So what we're certifying here is job skills that may meet some of those roles. And these are just names. I don't know in your organization specifically what the senior designer is called. But the idea is that this is a senior person. It has influence in the network. It has business relationships inside the company. So this is not the junior guy that we just hired out of school to help us design some little piece of the network. This is the person that is probably in charge of the network. So it says down here, its emphasis on network design principles are at the infrastructure layer. I know it says routing there, but this is not just about routing. It's about the infrastructure itself. Sure, we're going to talk about routing, we're going to talk about layer 2, we're going to talk about security, we're going to talk about management, we're going to talk about overlays and other things, and the ability to assess and translate business requirements and technical designs. Right, so at the end, what we want you to show us is a technical design. But what we're going to give you is we're going to tell you about a business. We're going to probably give you some actual technical requirements for you to incorporate into that business thought process to end up with the design of the network. So this is not a test, even though we've talked about business several times. This is not a test about budget. Right, so we're not going to ask you, hey, you have only $100,000, design something. Because we honestly don't care. We want you to understand the business structure of the company or the problem that you're working with, and take that into account in your technical design of the solution. So last night when we were at the party, there were a couple of guys who had just passed the CCD, and they suggested a name change, actually. I haven't told you. So CCD is called Cisco Certified Design Expert, right? So they said that we should change the name to just DE, Design Expert, right? Because even though we are certified as Cisco, right, that you're a design expert, he said this is not a test about Cisco. Right? We're never going to ask you, hey, you have an ASR 9K, can you put it over here in your network? Because if you ask me, I don't know what the ASR 9K does. And I shouldn't care from a design point of view. At the time of implementation of a design, sure. But that's not what we are testing here. What we want to look at are skills that you can use in network design that are going to transcend the test of time and whatever equipment we may be selling. Because we trust that all of you only buy Cisco. True? Yes? No? Nothing? Should I point the laser at them? No? So who doesn't buy only Cisco? I'm in the wrong room. I'm going to go over there. Over there, we're talking about ACI, Application-Centric Infrastructure, which is only Cisco. No? Damn. Okay. So at the end of the certification, you get a piece of paper that certifies legally that you only are going to buy Cisco. So just so you know, when you take the test, that's going to happen. You can sign it now if you want to. The small letters, that's what they say. Only Cisco, yes. If you don't buy Cisco, you get your certification taken away. Yep. Okay, so I showed you that little map there with the 6 certifications, CCNA, CCNP, CCA, whatever, all the design stuff. So what this tries to do is talk about the relationship between the CCDE and the other certifications. So well, okay, that's an okay picture. But the purpose of this thing, when we talk about, say, CCAE, CCDE, and things like the architect certification, the way I like to explain it is that you have, let's say at the top, the architect, who's going to have even a deeper relationship in the business. And this is the guy that's going to go talk to the CIO or the CEO or the CFO, people who don't understand networking and who can care less about networking, but they want their business objectives met. Right? So this is the person that talks the business language and ends up looking at the strategy of the business and comes up with, let's say, lighter business requirements or technical requirements for what the network has to do. So the architect translates that back and forth. We get those requirements, we hand them off to the DE, to the CCDE guy. He's going to go design the network. So we know from the other slide that we have different levels of CCD something, right? So there are different things that the different design people are going to do. The DE is probably going to be in charge of the whole thing. You're going to farm off some things to the CCDA or the CCDP guy to go do, you design the edge, you're going to design the access, different things. So that's the interaction between the different design people. Get stuff from the architect, do the design, and then we're going to go sort of hand that off to the CCIE, right? The CCIE is the guy who can go implement and configure and troubleshoot, right? So theoretically, in this continuum, we hand it off to the CCIE, who obviously works with the CCNA and CCNP and other guys to go implement the network. So that's a theory between what we're doing here. And I know that in many cases, you guys are the CCA and the CCD and the CCAR and everything at the same time. And that's fine. But from a testing point of view, from a certification point of view, we are looking at specific skills. And those are the skills that we're looking at, right? Those skills to interact with the architect, right? To get functional specifications. And we can give them back designs and plans. This is how the network design is going to look like. And this is how I'm going to get from what we have today to over there. So the architect goes off and talks to whoever they have to talk to about the impact to the actual business strategy or anything like that. He works with, say, the CCAE, right, where I give him technical specifications, and now I get the implementation plans. And now he's going to talk about, well, I'm going to do this first at the core, and then at the edge, or I'm going to go implement this firewall over there. And what is the actual implementation plan and process? So the intent was something along those lines. There's obviously a couple of things here that also require interaction, like, for example, the business side. How do I get business requirements or application requirements? And as we go through what the CCDE covers, we're going to talk about drivers. What drives a design? And we're going to tell you, well, clearly, business requirements, application requirements are things that are going to drive your design, so that at the end you know that you ended up with something. Right? In other words, we're not just going to tell you, oh, go design an MPLS VPN network. We're going to tell you, go design something that meets these business requirements, these application requirements, and other requirements around layer 1 and layer 2 transport that you already have. And then you design the solution. It may end up being an MPLS VPN network. And that's fine. But the point is, we give you requirements, you meet those requirements. Not necessarily just abstractly design a VPN network, for example. So those interactions are going to be obviously important. So this is the hierarchy inside the design world, and I already sort of alluded to this, right? The fact that the DE is going to be that senior network designer, maybe the boss of everyone else, or the responsible for the network, or whatever, where he has the ability to work on large-scale network designs, to work on every piece of the network. Whereas you go down the slide here to CCDP or CCDA, the skills that we test for and that we're certifying are simpler skills, let's put it that way. Where, yes, we know that you have the ability to do a small or medium network design. Where the DE is that certification that we're certifying that you can do anything you want, right? That you are the expert itself. So in the permit here, we mentioned the architect at the top. And again, this is the highest certification that we have. And it is that person that is going to still focus on the infrastructure, go look at those business requirements, right? The interaction with the finance and the strategy itself for the long-term architecture of the network. Right? The long-term architecture of the network doesn't mean that you can't change your design or go with a new technology 5 years later. It means, what is the long-term plan for this network? What are the things that we need to meet in terms of, business continuity, for example, or security or resiliency that tie directly to the business goals of the company? And then we, as designers, we take that and we say, okay, today I'm going to build the network this way, because I think a overlay of IPsec tunnels is the best solution for this, given those requirements, right? The AR, as it says here, is not focused on the tail deployments, the solutions themselves, or applications, or enterprise, or things that is focused on the high level. That's what the DE is for, right? To focus on the specific application requirements, to focus on the specific migration plan, to go and get to the place where we will actually go meet whatever goals the architect is doing. So I don't think we have an architect session this time here, but in general, what you're going to hear is that you first need to have a CCDE. That's how we know that you already know the technology, that you already know and have the abilities to design the network. So we focus on other things up at an interview and a board exam for the architect. The certification process is very easy. You do a written exam, you do the practical exam, and then you get the certification. Very simple, right? Nothing, no rocket science, just 2 tests, and that's it. Any questions? What's the prerequisite for the CCDE? Nothing, right? Experience. Nothing. Well, yeah, okay. Experience, yes. So what we found, and probably the best compliment that I think we ever got about the DE, someone said, the way that the exam is presented and how you sort of interact with your customer through the exam is just like my job. So we tried to design this looking at what would a design senior design person do. You interact with your customer, you get requirements, you propose solution, you ask for more information, you know, all these things. And that's what the test is about. So a very big part of it that we don't mention enough in this class today is experience. And you may know everything about OSPF and where all the bits are put and everything else, but if you don't have experience about designing and you don't know what other information you need from your customer, your design may not be too good. Sure, we can all put ABRs in different places, but you know, that may not match the requirement that we're looking at. So the whole test is driven on requirements. Yeah, so how many of you have done the written exam or have it scheduled? 1, 2. How many are going to rush out of here and take the test just over here to the left? Yes, so this is the closest point you'll ever be to the testing center. Yes, so be careful when you run out not to trample everyone else. Okay, so now we're going to talk about what the topics are in the exam. So of course, we're going to tell you everything because we don't have a lot of time. But there's a bunch of information online that you can go read in there what we're going to look at. So when we look at this, basically the simple way of looking at it is sort of the intersection of these three things over there. Intersection of technologies. We obviously want you to know technology, right? The intersection of what we call task domains, which are larger issues related to design. So these are things that as you get into a problem in the test, we're going to tell you, well, you know what, we have a network and we're going to go buy another company. How do we merge these? Or we have a network and we need to add streaming video for 20,000 locations or something. Okay, now you're adding a service. You need to redesign your network. We have a network and we're going to sell half the business. How do you divest your network? Right? So those are big task domains. And then the other part is job tasks. So these are smaller individual stuff that you're going to do for those bigger tasks. And as I already mentioned, we're going to give you requirements. We want you to ask about requirements. We want you to resolve conflicting things. We want you to provide answers to which way should I go. Should I use an LTTP3 tunnel? Should I use GRE? What do I use for this case, right? And I always keep saying for this specific case, because it's all driven by the specific requirements of that scenario that you're looking at. Not the customer you worked with last week, but the customer that you're working with now. That's probably the most important thing to know about the test itself. So when we do the written test, these are individual questions. I don't know how many questions there are, but there are individual questions that focus on technology. So each question is independent. And we're asking you about some security topic and how it applies to design. So when we wrote the test, we were thinking about that. How does this question apply to design? So it's not just about knowing that you can encrypt stuff. How does that apply to the design of a network? That's the important thing to know. And of course, in the practical, which is that other test in the middle, we try to, at every question, look at all three dimensions. Talk about technology, talk about the task domain itself, the big problem that we're looking at, and then talk about the different job tasks of the different things that you have to do to get to whatever answer we're looking for. So task domains, I said, the big ones, some of them I mentioned, right? We're going to add a technology, we're going to replace something, we're going to scale, merge or divest. Those are sort of the big categories. So you can already think about, problems that you have with your customers today that meet those things. I have a network, I have a business, I have 2 stores here in Melbourne, and now I'm going to go global. How do I scale my network?
This is something I mentioned from Thank you. So this is probably one of the important areas for people who are preparing a mind shift, people who are coming from the CCIE background. When you come from a CCIE background, you kind of need to change your approach in CCDE preparation because the task domains are different the way the layout is from the CCIE program. The CCIE program is very centric to technology, right? You have IGP, routing, and security, and BGP, and all those technologies. Over here, it's different. So you have to change your mindset on these task domains. And when you look at the blueprint, you'll understand more better how these task domains are laid out. So it's not like, OSPF or BGP or multicast. It's these technology domains, it's these task domains, and underneath are going to be plugged in the technologies. Does it make sense?
Okay, so task domains, right, big problems, and then the job tasks, things you have to go do to get that task domain solved. And when you look at this list, this is obviously a short list, but a very important one, right? We need you to analyze the requirements so you can come up with an actual design. We need you to implement and deploy. Here we're not talking about what is the configuration of the box, but we're talking about how would you roll this out in the network for, say, minimum disruption, for example. Or what are the steps that you're going to do first? Or I'm going to do the overlay first, and then later I'm going to take the routes out of the core, for example. You take the routes out of the core, your network's going to not get anywhere, so we know you got the question wrong, right? You don't know how to get to where you want to go. How do you validate and optimize? What are options that you're putting in your design that are going to help me scale more? Oh yeah, I'm going to just use BGP because it can carry a bunch of routes. Yeah, okay, great. But what is going to help me really in that design scale more, and how do I validate that against the requirements themselves? So these are the basic job tasks that we're going to ask you about. And of course, the question is not going to be how do you optimize, but we're going to ask questions that are going to look at that in the task domain for some technology as you go through the scenario that you're looking at. So when we get to the examples later, it might make a little bit more sense. It may not make more sense, but we'll talk about some of these things as we go into the examples themselves. And of course, we'll talk about the technologies a little bit later. We put this slide here, talking about essential skills. Reading, and this is not a technical skills, right? You don't need to, you need to read to know many things, but this is important because this is a scenario-based test. We give you a ton of information. You have to read that information. You need to be able to abstract the information and understand what we're telling you so that when we ask the question, you know how to answer it.
Is that going to be technology-based information?
Yeah, so the question is it going to be technology-based information or business-based information? Both. Right? So, you go to a customer and the customer tells you, here's what my business looks like. We're a retail store. We have stores here and there. This is what we do. Now we want to do X, right? And so, yeah, it's going to be a little bit of everything. It might be the topology. It might be the business plan. It might be different things. Now, the important thing to know is this. We tried very, very hard, that if you look at the questions and you don't know the scenario, you can't answer the question. Because everything might look like the right answer. Right? If I ask you, which routing protocol should I use? And the answers are, RIP, OSPF, BGP, and ISS, and EIGRP, of course. You don't even know what I'm asking, right? You don't know if I'm asking you internal, external, I have this type of topology, the other type of topology, I have equipment that doesn't run EIGRP or only runs EIGRP, many things. So everything is based on the scenario. And there are going to be things in the documentation that are going to steer you towards answers. So how many, if I gave you any problem, any design problem, in this room, how many different designs do you think we could come up with? As many, maybe more, right? Maybe some of you come up with 2 different designs or, something. So, that is obviously a challenge when trying to certify and test someone. Because I, of course, have to be consistent and test the same thing in all of you for it to be a valid certification. So what we end up doing is, through that material that you're going to read and abstract and everything else, that is going to guide your design. And so when I ask you which routing protocol to use, you know that the correct answer is EHRP. Because there's something in the scenario description that pulls you that way, right? It may be the simple thing of they are already running EHRP and they have no money for training, for example. So, maybe for that option, the best design is, well, let's keep EHRP. Because we can make it scale, we can make it converge, we can do all these other things. And it addresses some of the requirements and the constraints of the business itself. Okay? So we need you to do this and do this fast. We said reading, abstraction, right? Analyzing the information itself, understanding how they relate to each other. Here's the topology, here's the business plan, what do they have to do with each other, right? Or what is the relationship with respect to the answer that I'm supposed to go give for a specific question? And really, really important is, why would you do this? Why are you telling me that you're going to go put a GRE tunnel in your design? Why? Well, because the requirements say this, because this or that. Not because you love GRE or not. Not necessarily because there are rules of thumb that tell you, oh, yes, you're going to do the NVPN, and you're going to do this and that, and that may be the answer we're looking for, but that may not be the answer we're looking for, right? So we don't, So don't assume that because something is really popular or in demand or we do a lot of marketing that's the answer we're looking for, because that's probably the opposite assumption that you should make. Okay, so we talked about the task domains and the job tasks, right? Now we're going to talk about other domains. We couldn't come up with better words. Other domains and other drivers that are going to drive the design, right? So one of the things that we think is really important is that as networks evolve and grow and change, the focus on specific places like, say, the data center or the cloud, right? Today, every answer to everything is, just put in the cloud. Well, there are actually three different answers, right? One is everything goes in the cloud. The other one is SDN solves everything, right? And the other one is the Internet of Everything, right? So between those three things, you can solve any problem. We should make that the first question of the test. How do you solve this problem? We don't tell you what the problem is, and the answers are SDN, IoT or IoE, and the cloud. And if you answer anything, you fail the test and go home. How's that? Good? Make sure he doesn't get up. Yeah. Okay. So, we don't think it's about specific things, right? We don't think it's about also specific technologies, because as you all have seen over the last 10, 15, 20 years, technologies come and go, right? And today we're saying, well, centralize everything, put everything in the cloud, SDN, all this stuff. Tomorrow we're going to say something else. Or yesterday we said something else. Everything is distributed. And then now we don't only have cloud, we also have fog. Have you heard about fog? Right? So cloud is centralized. Fog is now distributed. It's just like a cloud that comes to the ground, and now it's fog, right? And you have the computing local but distributed, whatever. So these are things that come and go. What we want you to do here is not know everything about the cloud. Sure, we might ask you to go design a data center, or to tell us, what the optimum flow or packets is going to be between my enterprise and wherever the cloud actually is, for example, or how do I secure that? But we don't want you to go design a cloud just because we have to design clouds, or know everything about Ripple because IoT is really, really important. We want you to understand the basic principles. And sure, maybe how the FADs are going to affect the design of the network or not, how they're going to help it or how they're going to maybe even damage your design, right? So we want to look at that. So we look at the problem. We divide it into two pieces, basically. We look at domains. And so domains are going to be things like availability and resiliency and security and other stuff like that. So when you get that task domain of merging and you're analyzing and working on the design, right, the job tasks, we're going to have you think about the domain of availability. And so when we think about that, we're not only thinking about 5 nines or 6 nines. We're probably never going to ask you, make a design that has 6 nines or 4, whatever. But we want to look at, we want you to think about, NTBF, we want you to think about simpler solutions to the problem. Obviously, more complex things make it harder to troubleshoot and design and maintain and everything else. We want you to think about what the application really requires to run. So just because we can have 6 nines in the network because we tuned everything to the nth degree doesn't mean that that's the right answer. That is a more complex answer. Sure, it might address all the requirements from the applications, but the requirements might not even need to converge fast. Maybe the only application we have in the network is email. And who cares if that converges in 5 minutes? And so we design something that is, sure, it meets the availability requirements, but it's overkill, right? It makes the network more complex. It makes it more prone to failures later. It makes it harder to troubleshoot, to fix, to et cetera, right? So it's probably not a good design for the one requirement that we had, which was email, right? Just so you know, that is not a question in the test, the email question, okay. So availability goes hand in hand with things like serviceability, which is why I was talking about simplicity or complexity in a design itself. What is the mean time between not just failures but mistakes? If I design something really complex, and now not only my CCIE, but I need some guy with 10 CCIEs to go figure out the one box, well, this is really, really complex. And if he fat fingers, what is going to be the implication of that? How fast am I going to be able to recover? So it's about balancing, right? The complexity of my network against the serviceability of the network. And of course, the question we always ask being in support is, can you pick up the phone at 2 or 3 in the morning and explain to some tech guy in some other country what your network looks like in less than 5 minutes? If you can do that, then the design is simple and streamlined, and it's a good thing. If you need 3 hours to tell me what the network looks like, well, that's another 3 hours that you need to add to the time to repair your network. So think about how we're going to troubleshoot. We know you're not the CCIEs, maybe many of you are, but this is a DE exam, and we want you to think about that because you're going to hand this off to some other guy who's going to go implement this network. And we want you to hand off a good design, not just something that happens there. Scalability, and this is not just, I have 20,000 billion remote sites off my one router. This is about other things. Where do I put the services so that I can actually have those 20,000 billion remote sites? How am I going to do this? And it doesn't matter that I'm streaming video or that I'm doing voice or that all I'm doing is IMing between the different places. How does that impact my decision of service placement or convergence or other things that are going to help my network scale and be bigger and better and everything else? Security, of course, is an important one. Is my network secure? How am I protecting them? How am I vulnerable? How am I going to prepare and repel the attacks? Because we know that security is good, but it's a layered thing. And even though you have security, people are going to attack you and you have to respond. So part of the design is, how do I respond to an attack? Not just, I'm going to put an access list over there and that's it. But if I do find an attack, how do I respond to that? How do I protect the network devices, but also how can I use my network devices to protect myself against an attack? Can I use the network as a security response mechanism, for example? Because maybe the attack is not on the network, but on the applications or different things. along those lines. Flexibility. Not just do we want you to design something and tell us how to get there from where you are today, but it would be great if in 5 years, as the business changes and grows and whatever, we don't have to go completely redesign the network. But is this network flexible so that it can adapt to some changes? Obviously, if the company was doing something and now completely changed the business model, well, okay, maybe we can't keep the same network. But as things evolve, how flexible is my network? If I'm growing in only one region of, say, the country, do I need to go re-engineer my whole network, or can I just grow in that place, for example? So, different things, different considerations like that. So in the end, right, this is not just about hierarchical design. This is not about you memorizing all the Cisco validated designs and come and tell us what they are, because that may not be what we're looking for, right? We're going to give you requirements that are going to steer you in the direction of the answer. So we want you to look at those design drivers that we're talking about and then make the design with the technologies that would fit to solve those requirements. Again, not just because we're saying that ACI over the next room is so cool, you need to put it in your design. Right? We don't need every design to have as the end. Some designs are, okay, maybe fine to have it, but not everything. We want you to understand those drivers. We want you to understand the task domain. We want you to understand how this would happen in your network. And more importantly, to show us that you can do this. Because that's what the test is about, right? For you to show us that you can actually do this. Questions? Okay, so we talked about task domains and job tasks and these other design drivers and domains and things. Now I'm going to go a little bit deeper into the design drivers themselves. Why am I going to do this design that is going to be available and scalable and secure for the merge of the network, right? So there's several things that we look at. We of course look at things like business drivers that are going to be influencing how I make my design, right? So you want to look at things like, what is the sizing model of the business? What type of footprint, for example? How fast are we going to grow? How does the business model is going to change? Is going to affect the flexibility of my network, for example? Things around scale and continuity. Continuity requirements of, say, a bank, where you have pretty much a hub and spoke network, are very different than the continuity requirements of a retail store, where you also have a hub and spoke network, but the store is closed all night, for example. So there are different requirements there from a business point of view of things that you need to do. Right? The store might be okay to be autonomous, even during the day. The bank, probably not. So you want to look at those things that the business drives. Expense. And we mentioned before, this is not about budget. We're not going to give you some money and you have to go spend it. But it might be that the scenario talks about the fact that we don't have any money and we can't buy new equipment. So you need to work with what you have, for example. How does the network provide an advantage to the business? Why, if I choose to self-deploy an MPLS network, is that better than to go into a provider for an MPLS network? The technology is the same, the implementation and other things are going to be different. Why is that an advantage for my business? So there's going to be drivers that are going to mold the final design that you're going to propose. They're going to make you think about, well, it's not answer A, it's answer B, because this business driver is pushing me that way to do something. Then we look at things like application drivers, right? So now I have to think about, well, what are the things that I'm going to do on this network, and what do they need for me to do it? And so here we're talking about, bandwidth delay, jitter, all these things. tolerance for reconvergence, so how fast does my network actually need to converge is one thing. Other things that you may look at applications, for example, is not just the requirements of delay, jitter, bandwidth, all these things, but when you think about the design, where are you going to put these applications? Are they all in the cloud, or are they all distributed? Can I do caching for my video streaming, or different things? Because that will change the design of your network, and that will help you go towards the solution that we eventually want. Other things that you want to look at is obviously things like link drivers. What technology do you actually have to build these things on? I have these business requirements, application requirements, and I have this infrastructure there. Can I build what I need? Are there constraints in there? How do I do my layer 3 failure detection so that I can meet that application's conversion requirement, for example? Because the business required that for the continuity or for the survivability or for the whatever that we're going to do there. So we need to understand that as well, so that we can then propose a solution that's going to make use of, again, what we have and go forward into what we should have in the future. So if we look at these things, they all intersect in the infrastructure. Right? So we're really talking about infrastructure design, right? We're not talking about necessarily voice-specific design or anything like that. We want you to understand the characteristics of an application like voice and how, in general, it could be deployed. But we'll probably I don't know if never, but right now we probably won't ask you to design the dial plan for a voice over IP deployment, for example. It's important, but the CCD is about the infrastructure. It's about where all these things sort of converge and intersect, and where we get the applications, the higher level political business type things, and everything at the bottom together, right? That's where everything converges, at the infrastructure layer, which is what we're looking at here. Any question?
You mentioned two things, the dial plan and video caching. To me, they're very application. In a scenario, would you see something like this customer key application is video streaming and it supports caching, or would you be expected to understand that video caching could be deployed through localized caching resources?
Yes.
Yes, and then it would be.
So the question was, I mentioned a couple of examples of video caching, and so what his question was is, in the exam, will we see something that says they have a video streaming and it supports caching, or will it just say video, and we're expected to know and understand that caching may be an option? And the answer is yes. You might see either or, right? So I'm not a video expert, and I don't know if any of you are, but I'm sure that you know what a cache is. And those types of high-level things, we probably expect you to understand that. We expect you to understand that if you're doing a voice call, that there is some budget there for delay, that you just can't take 5 minutes to converge because obviously the voice call is going to go away. Those things, yes, we expect you to understand, but there's no deep, real understanding. Something deep that you really have to know about telephony, right? Or describe all the codecs, or whatever. Probably not. Now that doesn't mean that we might not say, oh, it has this codec that has these delay characteristics. That's a little bit more information. It's fine. But we might not say, oh, you have this G whatever codec, and then for you to know everything, because that's a different test, right? So yes, in some cases we might give you information up front. In other cases, we expect you to know some basic things. In other cases, we'll actually want you to ask for that information, right? Because, as I said, you need to read, analyze all this stuff. And just like a regular customer, you go and they give you some information, and now you have to make a decision, but you realize that you don't know everything about the network, or about the application, or about the equipment that they have, that you're expected to use in your design. And so you may have to ask for more information. So part of this, right, is for you to understand, not only to understand the requirements, but to be able to understand when you don't have all the information and be able to ask for that. So there might be a question in there that says, what other information do you need to define the video infrastructure or something? And then the lists are, well, I need to know the capabilities of the caches, or I need to know how big the stream is, or where the uses are, or the IP addressing of the whole network, or whatever. Right? And so that's how we're going to measure, and we're going to see whether you really understand what else you need. Because probably if you ask for the IP addressing of the network, for that question, it probably didn't matter. So the other part of that is that, yes, we'll give you information up front. And we expect you to go read some stuff before you even start answering questions. But then we'll give you information as the test goes on. Either because you asked for it at some point, right? Or because we now say, oh, you know what? That's great that you recommended this thing, but they decided to go implement this other network. And so now we give you the topology of the new network, and now you have to go deal with that. So we go changing things, add some stuff, give you some information, ask you about whether the requirements are enough, or if you need extra information, or different things like that. Any other questions? How linear is the story? Is that what you asked? Yeah.
So when we started designing the test, we were of the opinion that if you couldn't ask the right questions, then you should fail the exam, right? If you didn't realize you needed more information, if you didn't ask for that information, hey, you can't be a designer. And we got smacked around by our test design people going, well, wait a second, that doesn't make sense, because analyzing information and understanding what you have, what you don't have, what you need is completely different than if I give you a set of information, what can you do with it, right? So in the sense that the questions are linear in that I may present you with a question that says, what additional information would you want to know? Or what don't you have that would help you solve this problem? I want to ask that question, right? And you're going to tell me what you think you don't know. But after I ask you that question, I have to then level set you. And I have to give you information that says, okay, by the way, did you know, now you know this. And it may be the information you wanted to know. It may not be the information you wanted to know. But you now have additional information in order to make some further decisions, right? So you do go in that linear fashion. I can't let you go backwards, obviously. Once I say, oh, you should have known that you needed to know the latency profile of application XYZ. I can't let you go back and go, oh, yeah, I would have liked to have known the latency. That would have been great, right? But we do step you through in that fashion, having you analyze requirements, telling us what you know, what you don't know, and such, and then level setting you as you go along so that you can then do the next step, the next task in the process. It's not how we wanted to design it. We thought you should fail, but they told us we were stupid. So,
yeah. So there is continuity, right? But as Bruce just said, right, if you fail one question, that doesn't mean that the rest of the test is lost. Right, you lost a couple of points because you requested the wrong thing. But we give you something else, and we level set you because, again, this is a test, right? We need to test all of you on the same thing. So we can't ask you the next question unless all of you have the same information, right? So that's why we need to level set you. But yeah, it's a story. Once once the customer said, I'm going to do this, we don't go back to the initial network and redesign it again, right? We just keep going forward. So the question is, yeah, but I'm going to select the option that says give me everything. Well, first of all, it's not an option. And second of all, you're probably going to get it wrong too. because that shows us that you don't really know what you want, right? So whether you answer the question incorrectly and you then ask for that latency profile, when we were going to ask you, when we tell you, what did you need to know for this? And you didn't ask for that, and you ask for everything, it tells us that you don't really know, right? So you still lose those points probably. No, and this is a multiple choice test, right? So it's not like you get up and ask for stuff or anything. At some points, we ask you, what else do you need to know? Or, things along those lines. What information is missing from the requirements to do this? Do you have enough information for whatever, et cetera? So at some points, we give you the opportunity to tell us, to ask for stuff, or to tell us what you would ask for, right? At other times, we just give you some more stuff and say, hey, instead of asking you, we just say, okay, here's the delay profile of the application. Here's the next question, right? So it depends on how we structure the exam. That specific scenario for the exam. Okay, so we're going to go into the technologies overview. What? Yeah, no break. Who needs a break? Good, we're not going to give you a break. So I mentioned before that this is not a talk where we're going to teach you technology. So the overview is an overview, right? We're going to talk about some technology. We're going to make assumptions that you know a lot of things, and talk about, in a design scenario, why would this be better, or what things you look at when you look at technology, for example. We're, of course, not going to cover everything, but when you get slides, you'll get some more information there. So the first question is, what do you need to know? Everything. That's the other reason why we can't cover everything here, right? Because we don't have enough time. So anything. Any published document, any common industry technology, any common industry practice, EHRP, which is a common technology and a common industry practice, and it is now a published draft 2. So anything, right? Anything is fair game. Now, keep in mind that this is a test about the infrastructure. So we just talked about. Yeah, we all understand, because we've read an article or two about video caching and things like that, and how it's nice that I cache the video there so that I don't need to go back to the cloud and get the stuff, right? Yeah, we all understand that, because at least we've read some articles somewhere, or we know because we're downloading Netflix from the cloud, and we know that it's better to have the Netflix data center here in Australia than to have it in the US, right? So we all understand things like that. Maybe we don't know all the details of the video frames and whatever. We need to do that, because we're talking about infrastructure. If there are things that we think that you really need to know about the video frame, we'll probably tell you in the information that we give you, if we think that's something important. Of course, just like any customer that you have ever worked with, you might get information that it's completely irrelevant, right? That it doesn't matter. And again, that's part of you analyzing and understanding what is relevant and what is not relevant. Why is this important for me to answer the question, or why wasn't it just another list of IP addresses that I got? Okay, so we have to know everything. This is not, and we said this before, about configuration. So we'll never ask you about a command or what happens if you configure this with that option or something. That doesn't matter for the DE. I know that, again, many of you are CCIE, so you're going to go implement this anyways. But the important thing is that you understand the capabilities of the technology, not the configuration options that we may have. This is not about the right equipment, because, again, hardware changes, the limitations. Now the hardware is bigger or smaller, or they have different abilities, so we don't necessarily want to ask that. So we won't ask you, why did you put an ASR 9K versus the 1K or whatever over here? That's not what the test is about. We want this to be skills, to test skills that are going to be valid for many years, right? And those skills are what we've been talking about, right? The ability to work on this domain task, to analyze, to get information, to show us that you understand business, application, layer 1 type drivers, and get all that together and put it into a design. Those are the things that are going to be timeless. And note that in any of that thing that I just said, I mentioned anything about technology or about a box. Computerless IT, wow, that is very cool. Okay, so that's that. The main question that you want to ask is not really why do I care, but how does this that I'm thinking about or that I know about technology impact the design? That's why you should care about something. Bruce said something really important earlier, which is, what is the prerequisite for this test? You don't need to have any other certifications, but you need to have experience. That is really, really important, because if you have experience in design, you start looking at things that you know in the different technologies and thinking about why is this important when I apply it to a network design. So we all think about, I don't know, OSPF areas or things like that. It's great that you understand that you can put areas. It's cool that you can go configure an ABR. Understanding the impact of separating flooding domains for, I don't know, maybe resiliency, that's a good thing. For maybe convergence, why it may be good. But now you lose end-to-end visibility. So even though we're all taught to go do areas, now you don't have end-to-end visibility. And for whatever applications you're putting there, end-to-end traffic engineering, for example, it may not be the best answer. So we want you to think about, why is this piece of knowledge that I have in my head important for design? The other piece of knowledge that you have based on that is that you put a bit, the B bit, I think, in the router LSA to say you're an ABR. Who cares, right? It doesn't matter. That is not important for design. What is important is the function of the flooding domain and how it may be good or bad for different applications. So that's what we want you to think about. Not about the bits, but about the applications themselves. Okay, so we're going to go through different things and talk about different technology. I guarantee that you are probably going to disagree with many of the things I'm going to say, which is fine. We can discuss all you want. The intent here is to show your technologies and then show potential places where you might consider one technology over the other. We're summarizing, of course, the case in like one slide. So, there might be other considerations that you want to look at, but in general, we're trying to simplify it so that you see why, or that you understand why we're thinking about what we're thinking. So when we talk about layer 2, one of the topics that comes up, of course, is things like layers, feeds and speeds, right? And everyone talks about, well, I have my 24 or 48 port switch that I put here, and it's in the axis, and then, et cetera. We're going to look at this, very broadly in the CCD. We don't necessarily look at the specific questions of how you aggregate your bandwidth and things like that, because you today bought 24, tomorrow you buy 48, the next day you buy a 96 port. There's other drivers around that. We're going to look at other things when we talk about layer 2. For example, the technology that you use to build your campus or maybe your data center. So in general, there are two things that you can do, right? You can do spanning tree. We all know and love spanning tree, right? Who hates spanning tree? Wow, 3, 4, 5 haters. Wow. Okay, so you know what spanning tree does, right? And it builds a tree, and so some links are not used, right? That's the basic operation of spanning tree. You build a tree. There are some links that are not part of the tree, so you don't use them necessarily to transit traffic back and forth. It has some convergence properties of Bellman-Ford distance vector similar to RIP, in that you need to reconverge by saying, oh, I'm the root, I'm the root, I'm the root, and you reconverge around link failures or maybe node failures by homing again back to the root. So it takes some time, right? It's slow. In general, if you have, say, north-south traffic patterns, you know that if you design a network for spanning tree, you have to put the root at the top, because all the packets are going to go to the root of the tree and then go to wherever they go. Right? So if the root is up there, the traffic's going to go there and then come back down. if the route was here, then the traffic is going to go, say, like that, and get to different places. So we know basic stuff of spanning tree. Other things that we can do is we can do things like some layer 2 fabric. So layer 2 fabric like what? Like fabric path, trail, right? There's this 802 something SPB, right? Service provider bridging that the IEEE did. All these are layer 2 fabrics, right? And they have similar characteristics. They're basically a link state control plane. They're ISS at layer 2, routing MAC addresses, pretty much. So this gives you advantages, like I can use all the links, right? Because with spanning tree, on purpose, I blocked stuff. Here, I don't necessarily block stuff. So now, say east-west traffic, say from here to there, in the spanning tree would have gone all the way up and down. Here, I go there. So it gives me some more flexibility for traffic patterns in my network. Of course, sometimes it says here they're more difficult to deploy. Even though Trill is one of the standards, or SPB, L2MP, or fabric path, or whatever we call it, is not exactly the same, right? So there's some issues there. It may be more complex because now you have link state protocols running. It's not as easy as knowing, oh, the route is there, and that's it. All the traffic goes that way. So if the question is, what would you use? You guys that hate spanning tree are probably never going to answer spanning tree. You're going to answer whatever else. But if the scenario says something like, you're designing a campus network, and most traffic is going to be destined outside the network, right? You have all these guys with those computerless things connecting to the edge, and all the traffic is going to go out of the campus. So what do you use? So in this case, maybe the best solution is spanning tree. The route at the top, all the traffic goes up and down. You're optimizing, right? It's a simple implementation. You don't have to worry about traffic going in the wrong direction because there's some better links that seem to be okay across the hierarchy. So I know, as I said, this is a very harsh simplification of a problem. Right? We're saying north traffic, what would be better? Obviously, if you put Trill, it'll work too. Right? You can still do north and south. But because we're trying to constrain and direct you towards something, right? Those are the things we want you to think and look at. We talked about simpler design, for example. Well, obviously, spanning tree is simpler than something else if you get the route in the right place. So it's things like that we want you to look at and think about. Just because the technology is old doesn't mean that we don't want to use it anymore. When we talk about layer 2, we're also thinking about things like detection of failures, because we have those requirements about convergence and availability of my network or my application. So an important thing is going to be, well, how do I detect failures here? And now you want to go look at, right, when this fails, how does this other guy here know? And is there an inherent mechanism in the layer 2 that's going to tell me, for example? Do you have to go poll? How do I find out these things? So in this case, because there's a switch right there and 2 routers, if that goes away, the only way that he can know is if you send something back and forth. BFD, hellos, whatever you do for things like that. So there are things that we can do, right, of course. BFD, fast hellos. That doesn't mean that is the answer for every failure scenario. For this failure scenario, we have the layer 2 box there? Sure, okay. But there are, of course, other layer 2 technologies that have other ways to tell us that the link failed. Many networks are built now back-to-back, right? Your data center, your access, everything is built back-to-back. If I have a fiber directly connected to him, I'm going to be able to detect that the link went down, the light went away, a lot faster than I can send a BFD packet back and forth. So it is the understanding of when I need the technology and why do I need it. And the cases when I don't need that technology because there's other mechanisms. in there. And of course, this goes to complexity. I have protocols running that I don't need to be running. For example, if I have loss of carrier in my network, it goes to overhead because now I'm sending hellos every 10 milliseconds to 1,000 neighbors and scalability of the box and a bunch of other things. So we need to understand the abilities or the capabilities. And just because everyone thinks BFD solves a bunch of problems, it doesn't mean that we have to use it in every link. So we want you to understand that there are different capabilities that may happen. Failure domains and broadcast storm and things like that are, of course, can be very popular in layer 2. We want to look at those things, how they can affect the network. Where do I really need to propagate these broadcasts? I mean, sometimes I want to propagate broadcast information further. Sometimes I want to limit it. I want to then think about those failure domains, those places where I can stop things from propagating, where I need to put that layer 3 boundary so that I break down my huge layer 2 and do different failure domains. Not only that helps me with broadcast storm, it helps me with, if I have failure, I can now keep it localized. And so this sort of takes us back into layer 3 failure domains with OSPF or other things like that. I can use technologies like, say, IGMP snooping to better understand how I need to distribute my multicast. Because I have this huge layer 2, right? And multicast works on outgoing interfaces and where my receivers are. So in layer 2, it looks like one link, right, from layer 3. So we want to potentially use technologies that are going to, in this case, save network resources, prune off parts of the graphs that we need to send, because we don't have the visibility necessarily in layer 3. But with things like IGMP snooping, where I learn who wants to receive a specific multicast, I can now make my network more resilient. I can make it scale better. I can make it provide the service, et cetera, et cetera, et cetera. So think about, again, why would a specific technology help me in the design of my network? In the tasks that I'm trying to achieve of, let's say, scaling, this is a good thing. In the task of merging a network, well, I don't know, there might be some applicability for something like this, but think about why in the design domain that I'm looking at for the requirements that I have, why is this technology important in the design? Not just, let's put all the knobs that we know about in the network. Along the lines of multicast, again, multicast, we're going to do multicast replication, for example. The decision is going to be, well, where do I replicate the packets? In this simple network over here, we have, I guess, A is the sender. We're going to send packets that way. So a question may be, where are you going to replicate the packets? Right? Because you have more than one receiver. So where do you replicate it? Do you replicate it here, there, or over at the back there? And from the basic understanding of anything of replication, sure, you can replicate it anywhere. Right? Technology-wise, you can replicate it anywhere. Which one is the better design for the application that we have? That's a different question, right? And so obviously everything that we're going to ask you is not just, okay, where are you going to do it or where can you do it, but where should you do it for that specific design or deployment. So closer to the destination is obviously better, because that way we save resources at the core. In some cases, sure, I know that we may be able to replicate even before we get over to layer 2 at the end, because you might have a more sparse set of receivers that want your information. So sure, you may still see 2 or 3 flows across the network and then replicate it at the edge. Right? That's fine. But so that you understand that you don't want to replicate everything at the source and send 1,000 streams, you can do it closer to the destination, for example. So this is important for scalability, it's important for convergence, it's important for some other things in there. Things like first hop redundancy. And again, how does this help my design? I don't just want to do it because it's a good practice and all the guides show HSRP configured and you use it and have the backup. But I want to understand from a design point of view, why do I want to do this? Why is it important to have dynamic configuration at the end hosts? Why is it going to help me maybe achieve my convergence requirements, my resiliency requirements? And then on the flip side, what type of potentially complexity or hardship and troubleshooting, et cetera, is this going to add? Right? Because remember that every time you add a feature or add something to your network, now it adds some complexity, and now you need to go troubleshoot something else. So in the case of first hop stuff, probably the complexity is not that much compared to the advantage that it gives us in terms of flexibility, in terms of reliability, resiliency, recovery from failures, a bunch of things that it gives us to do that. But again, the important thing is use it where it makes sense to satisfy the requirements that you're trying to solve. Because, we may ask you, hey, do you want to use HSRP? And the answer is, yeah, sure. And then the next question is, well, why? And the answer shouldn't be, well, because, it's cool and I want to configure it, I configure it everywhere. The answer should be, well, because there's a requirement that tells me that I should use it or is going to address this specific thing. So every time that you say you're going to do something, make sure that you understand why. Not just because you always do it, right? But why does it for this case, for this scenario? Why is it important for you to put it in there? So as I said, there's, 20 other slides in layer 2 that talk about different things. In layer 3, we know things that we need to know. We need to know all the protocols, ISS, OSPF, BGP, EAGRP, PIM, only sparse and biter. We don't list RIP there, but I know all of you know RIP, right? So you should also know RIP. There is, general theory. How do we maintain, discover, and form adjacencies, for example? Again, the point here is not to understand which bits you set in the hello, but to understand how the adjacencies are maintained, because that may have an implication on scalability, for example. How are things sent around and best paths calculated in your network? If you look at, for example, a big hub and spoke network in one area in OSPF, well, we all know that everyone in the area needs to be synchronized. So that means that every time that the spokes change, I need to tell everyone else. If you have something that is not very stable, things that flap all the time, that means there's a lot of control plane traffic going back and forth. This may not be the best way to do this. If you have to use OSPF, maybe there's other ways to do it. Maybe there's other protocols to think about, depending, again, on the scenario, the requirements, on other things along those lines. We need to understand aggregation. We need to understand things about interaction between the protocols and what are protocols really made for. Sure, I can use OSPF or ISS between me and my service provider. Sure, I can do that. But that's not what it was made for, right? We want other things that have better policy descriptions, like BGP, for example, to do the external routing. How do I get that BGP to interact with my internal OSPF or my ISIS or EAGRP is an important design question, because that is going to determine how the flows go through the network. Where am I going to have maybe congestion? Where am I going to have different things that are going to affect that delay budget that I have for the application? So in the end, right, you want to look at all the different layers and figure out how the things are going to affect the fact that you have to make a technology decision. So things that you want to look in the control plane, of course, modularity, hierarchy, resiliency. We don't necessarily want you to always design layers that are access, distribution, and core. 2 layers, 1 layer, it depends on what application you're going to look at. But it's important that you understand the value of hierarchy, for example. Why is hierarchy an important thing, and why would that be important in my specific network? So if we have an example like, if we're going to choose the right core looking at these different things, what the different pieces are going to give us, right? If I have modularity, this gives me the ability to add or change pieces of the network in some sort of a cookie cutter type way. Where, I don't know, I have a university and I have different buildings or campuses, where if I build the building network in a specific way, now I can add another building and another building and another building and not have to go redesign the building every time I get to a place. It gives me the ability to grow the network, gives me the ability to put separation points so that I can do security, so that I can do aggregation, so that I can hide some information if I need to hide some information. So I can do different other things that are going to help me grow the size, or scale, or et cetera, right? So the result of what we do with modularity, you usually see it through things like hierarchy and virtualization of the network or aggregation of the network around different places, right? So when you modularize a network, you're going to look at things in general, right? Look at different pieces of different places. And you know, at the beginning I mentioned that, you know, this is not a test about places in the network, but understanding the pieces of your network, it is an important thing, right? So in this case, you know, it's a simple example, right? Where we have some hub and spoke, where all my retail stores are, for example, and I have this weird network, I don't know why, that is a full mesh in my headquarters. So if I'm going to look at modularity, you know, it's very simple. I have my headquarters that has a specific function, has specific requirements, has a specific topology, is deployed in a specific place. And then I have this other module, this hub and spoke, that has specific requirements, specific functions, specific everything. So I can now separate that. And I could go say, well, I have this, my hub and spoke for the southern region of the country, and I'm going to put another one just like this over there for the northern region of the country. And so it makes my life a little bit easier. Now, obviously, the key is to be able to define those modules and then be able to define how I could build, like, you know, Legos or something. How do I build my network based on modules? So things you want to look at when defining modules, right, or separating things. Complexity, right? Where is the complexity in the network? So if we look at that, right, I mean, obviously that is complex. Right? There's a bunch of links and a bunch of stuff going on. So maybe we want to separate that from other places. We want to look at, is the network already modular because of geography or because of function or, you know, because of other things? So I can separate those pieces. I want to look at how, right, and how am I going to work with aggregation. Aggregation not only of IP addresses, you know, a bunch of /16 and so /8, for example, but aggregation of topology as well. How is that going to help me grow or not grow, or actually meet my requirements for the network? How is the aggregation of the topology going to be good for my design? How do I re-originate, if I need to re-originate, information at the specific choke points, or the specific transition points between the different modules? And of course, what is the best place to do that? So modularity is, of course, very tied to hierarchy. Because in some cases, or in many cases, you're going to have modules that fit different hierarchical places. So when we do hierarchy, right, in general, we talk about access, distribution, and core. We're looking at things around, for example, hiding reachability or topology information. Right? When you put an ABR in OSPF, not only are you isolating failures, you are hiding topology information. I don't see what's inside the area from outside. So what is the advantage of that? How is that going to affect my design? Why do I really want to put it there and not a couple of routers that way? Or, you know, some other places. So there's things that I need to understand there. So we want to remember, you know, traditional designs, but we want you to look at how the network is really laid out. So, you know, even though you may think, again, core access distribution, we want you to look at how the network in the hierarchy and through the modularization separates different places or different nodes, different functions, and think about it more that way than just about core, distribution, and access, because that may be a lot more simplistic than anything else. So one thing that we do say here is that when we talk about hierarchy, for example, right, we're separating pieces of the network, places or functions, data center, the WAN, the campus, things like that. We're separating them by hiding information, which means creating failure domains, avoiding failures from one domain to affect other domains. That's one of the uses or one of the results of hiding information. We want to, in many cases, organize the network around a network core. And this sometimes comes naturally because the network core is maybe the headquarters. That's where the security is applied. That's where the policy goes. That's where all the communication goes to. That's where the cloud or the data center actually is. So we end up with designs that in many cases are hub and spoke type designs. The traditional hub and spoke where I have 1,000 routers connected to one, but they end up being hub and spoke in the sense of this here, right, where I have my headquarters and I have different functions, and these different functions may still be in my headquarters, right, my campus and my data center, and different things that have a common connectivity model. In general, designing networks like this makes them converge faster than if you did something like a circle. And this is because, of course, everyone is one hop away from where you can repair the failure. Where in a circle, you may be more than one hop away where you can repair the failure. So just the propagation of information makes it easier to converge a hub and spoke easier than a circle, for example. Because again, all the flows, all the information goes through one common place. Note that here, each one of these routers represents a function or a whole network in itself, right? So we don't have only 5 routers in that network, we have thousands of routers in that network. So another thing to think about hierarchy is, of course, all the functions that are going to go into the network. Where am I going to go put filtering? Where do I only really care about forwarding? And of course, if we talk about forwarding, usually what we say is in the core, you're going to have bigger routers. They're going to have more traffic. We don't want them to necessarily go analyze every packet as it goes through. We want it to forward, where the function of filtering is going to be probably at the edge, where even though the boxes are smaller, we have less traffic per box, right? Less information to deal with, so we can do network access at the core, at the edge. And of course, there's other things that we want to do, like traffic aggregation or policy and route aggregation, that we're going to do at other places. And we didn't want to put it here like a distribution, but maybe in the middle. It may be something that you actually put at what would be the core, or what you put at what would be the axis of your network. So you want to think about where do these functions fit? How does the hierarchy and the modularity fit together so that I can have the module function match some of the things that I'm going to put here? And if I do build that hub and spoke type modular network, I do want to put, say, access control at the edge, right? Not necessarily at the edge of my core, but at the edge of the whole network. So you start thinking about the design in multiple continuums, right? Hierarchy, modularity, traffic flows, network functions, many different things like that. So here we try to put a couple of examples just so to clarify what we're talking about. So in this case, this is a 3-layer example. And what this is some buildings here, which may be, I don't know, a university, for example, or something, where we have a core, and each building represents its own little module. And so we call this a 3-layer design because we have probably, say, a layer 2 network inside the building. That's one level. Then we have the, what would be the core of the building that is connected to the backbone that connects the rest of the network. So we end up with a 3-layer design. Some of the functions, route aggregation, in this case, we said we can put it here at the core. There's going to be other things like traffic aggregation. Obviously, at the building edge routers, we aggregate all traffic, and then we distribute it in different places. Now, if you look at that design, obviously the core is not just these 4 routers necessarily, but some of the links between the routers at the buildings, you may consider them to be core as well, right? So there's not that specific separation of this is just core, this is just access, this is just distribution, but some of the functions may be, of course, mixed in different boxes or the same boxes. This is pretty much the same as before, but all we did here is we took that little core in the middle and we put it outside, because now we're scaling a little bit further. Instead of having 4 buildings, now we have 8 buildings. And so we have this backbone over here with a local backbone in the middle there, and each of the networks has its own hierarchy. So this is an example of what we call layers within layers, where inside the building you have, say, 2 layers. Now, for each one of these campuses, we have the 3 layers that we mentioned before, right? The one here, the one there, and the one in the middle. And you can just look at it as a 2-layer hierarchy, which is the backbone and the building, even though the building has 2, right? And then up here, you could look at it as core and campus. And that's it. You can look at it as a 2-layer hierarchy, where inside this layer we have backbone and buildings, also 2-layer. And inside the building we have the layer 2 and layer 3. So we have 2 layers. 2 layers between 2 inside 2 layers, inside 2 layers, inside 2 layers. Something like that, right? So, this type of design is not rocket science, right? It's just keeping track of where the modularity goes, how that is going to affect, help, or damage the traffic flow, the design that I have in my network, how it's going to help me in achieving the goals that I have for the design of this network, whatever the goals were to doing this. Another example of layers within layers is what we talked a little bit about before, which is not necessarily a physical breakdown of the network, but a logical breakdown, where we have my external networks, right, which for all practical purposes, from my point of view, they're just a module. They're outside, right? Maybe if I'm an ISP, one is my customer, and another one is my upstream provider or the global internet. So if I want to look at that as a module, even though each customer may be different, I can, right? It's very easy. I have a customer, I get some routes from them, I send some routes to him. That's pretty much the interaction. And then I have in my network, right, the physical network, and here what we're doing is we're saying, well, we have our OSPF domain, and on top of that domain, we have a logical domain, which is the BGP domain. So I have all these external modules, and the only way I interact with the external modules are through my BGP routing domain. There is interaction between the two, right, because I need next hop reachability, of course, but the OSPF domain is pretty much independent from my BGP domain, except for the next hops, right? They are completely independent. So I end up with 2 layers of hierarchy here from a logical point of view. And anything that we can talk about hierarchy and modularity and how I separate functions applies not just to physical topology, but of course to the logical implementation as well. Because here I'm doing the same thing. I'm taking different modules, giving them different functions, expecting different things from them. They have some type of interaction, but they are completely independent. So I could take away my BGP module, and my OSPF module should still work. Or I could take away the OSPF module, except for the next hops, and my BGP should still work, right? So it's a modular design. So things that you want to consider, right? So let's say that we have a network over there, and we're going to add another layer or another module. So things that you already built may help you add to the network. So we talked before about not just scalability and resiliency and all those things, but we talk about flexibility, right? How does this network grow? So we want to consider different options, for example, to adding things. All the existing hub and spokes in here, for example, rely on a set of core routers over there. Well, that's one of the options if we have to add a new one. Just add it to the same existing ones. In here, what you see is that we're adding some extra routers that are going to support the extra hub and spoke. So probably for this drawing, what we came up to the conclusion was that, I don't know, maybe these routers are not going to scale anymore. Maybe we need to do some separation of the traffic. Maybe we want to isolate this from the rest because, I don't know, this might be our production network, and for whatever reason, we're doing some staging over there. So we want it to be a separate, completely separate module. So that's why we were putting separate or parallel sort of core routers. There's different reasons why you may want to do a build out like that. That may be because of the modularity and the operation of the different pieces, but it may also be just because the simple answer is, well, I just didn't have any more ports there, right? So I can't do the double connections down to the spokes. I have to do another set of routers. So sometimes that is going to obviously affect the design. And even though, again, in a sense, we're not asking you about boxes or routers or anything, that may be a consideration at some point, right? You need to expand, but without, but the capacity on the routers at the top is already full. So how do you do that? So when you're evaluating some of the hierarchy and things, right, you want to ask questions about, where are these places in the network? Where are the modules? What are the functions that I'm going to want to identify in each one of these modules? How, and to me even more importantly, why are you going to isolate them or separate them? What type of information do you want to hide between them? What information do you want to share between them? Right? Obviously, you want to share reachability information. You may want to hide topology information. Can I just take a black box and put it in place of any one of these modules and still explain the network? Right, so we talked about that ISP network before. We had the OSPF and the BGP layers. And I said, well, the customer is just a module. For all practical purposes, I probably don't care what the customer actually looks like. I just care they're a module. They're a black box. They're a customer. And that's it. And then I have my other provider or my upstream, and they're another black box. If I'm looking at, say, policy exchange, for example. If I'm looking at traffic flows, well, maybe I care because now that other provider has multiple connection points to me. So now I have to figure out which way am I going to go out. What is the shortest path? Do I do hot potato or cold potato routing, or what the heck do I do? And then the other question about the functions, right, of the network. Am I going to do functions per module, like access control? Do I do network functions? How do I do the network functions? So it's going to be modules that don't have, say, access control, because I did it at the edge modules somehow. So that's why it's important to be able to identify these places and this black box type thing and characterize it in terms of function and in terms of operation and what the characteristics of each one of them is. You have a question? You have a question? No? Oh, I thought you were getting the microphone for something. Oh, okay. You were just getting it away from him. Good job. Thanks. So, we already said all these things, right? We want to keep it simple. We want to consider why adding another layer or taking a layer out is important to satisfy the requirements. What is the impact? If I take a layer out, does that mean that I now have less routers and I can convert faster? Does that mean that my network is simpler because that layer actually was doing nothing and I can now consolidate the layer into my core layer, whatever that may mean? So we want to take that into consideration, take into consideration the traffic flow. If I add another module and now I need packets to go that way, now it's going to take them longer to go through my network. There's going to be, an extra milliseconds at every hop, so now maybe my voice budget doesn't work. Or now it takes too long for my customer to receive the video that I'm sending. And so, what does that mean in my network? So yes, you want to modularize, but you don't want to go overboard. Now, I see many customers that the examples that I showed before where maybe there were some of the edge routers in those buildings that were doing local building functions and core functions at the same time. We put in the same box multiple roles. There's some people who don't like that, and they actually put two layers of routers, one that only does building and the other one that only does core. regardless of the fact of whether the routers can actually scale or not, or whether they have enough ports or not. They just want separation of function. That's fine. But again, now we have to consider, okay, now I have an extra hop, or 2 or 3 extra hops in my network. Does that affect my applications? And hopefully in those cases the answer is no, it doesn't matter. So we can do that. We can do separation of functions. It's a lot easier to look at what the module looks like and be able to take the module out. Change the module, change the edge router without affecting the functions of a different module, for example. So you can do that, but you don't have to always physically separate everything. You can logically separate them if you want to. Okay, so the other topic, we talked about scalability or hierarchy and modularity, resiliency, right? This is, it says there's a general measure of the network ability to support business continuity. This doesn't mean that the network is up all the time. It means that the network is up enough for the business to operate. So some people say 5 nines, whatever, things like that. Here we want to look at the ability of the network to adapt to changing conditions. The ability of the network to recover and route around or adapt through hard failures or even soft failures, which are going to be harder to detect. If my links go down, that doesn't necessarily mean that my services are going to go down. It means that I have to go rearrange the network somehow so that I don't use those links. So usually that means I need to reconverge my routing protocol. I want to look at the modules and the hierarchy and everything else that I did before and see how that affects the convergence. If I have no visibility about this module and I don't know that I can go through there to get to some other destination, then I'm not going to use that. So what is the effect in terms of stretch, in terms of latency, in terms of just the performance of the application itself? So again, failures don't mean that your network is not working. It means that you need to have the network adapt to whatever changes in the network are happening, because changes in the network are going to happen. And so we need to make sure that the network can adapt. So when we talk about resiliency, there's many different topics, things like redundancy. So obviously if I have a link that's going to fail, well, I can just put another link. Right? That way one fails, I have the other one. So redundancy is one topic that always comes up. And as it says there, in theory, it's easy because I just have to add links. Well, what if 2 fail? Okay, I have a third one. What if 3 fail? Well, I have a 4th one. But in reality, it's not about this single piece of the network, right? It's about the end-to-end resiliency and redundancy of the network. And also the other thing that we need to consider is that not only is this a group of interacting systems, as it says there, but there comes a time when I just can't physically add another link because the router ended up not having more ports, or because I don't have any money, or because sometimes that is going to affect the operation of the protocol itself. And so even though I have more links, the protocol is now going to converge slower because I have to go converge with more neighbors, for example. So I have to think about all those things and have the trade-offs of, sure, I can put another link, but now it's going to not only cost me this, there's this other complexity, it's going to converge slower, et cetera. Do I really want to do that, or do I just put 2? And in any case, I have the ability to, or I assume that only one is going to fail at any time. Around redundancy, one of the things about adding links, and this came from some study that we did at some point, is that the more links that I have, right, as I increase the number of parallel links, the mean time between failure is obviously going to increase, right, because I have more diversity, right? But also the mean time to repair increases. So there's a point in here that the more parallel links that I have is okay, but after that, my mean time to repair is actually a lot higher. So having more redundancy is actually not a good thing in some places, right? 2, 3, yeah, sure, that's normal operation, normal stuff. 25, that's probably up here, right? And the number of neighbors I'm going to have, the number of that's going to actually affect, to impact negatively the performance of my network. So don't give us the answer of, yes, I'm going to put 25 parallel links to solve the problem. There has to be a different answer, or there has to be justification, right, to be able to do it that way and understand what the trade-offs are. Right, those are the important things. So things to look at, right? We already talked about don't overdo or underdo. The rule of thumb is 2. Now, we already said this is not a test about rule of thumb. So when we ask you the question and one of the options is 2, you might not want to select that one. Because the next question is going to be, well, why 2 and not 5? And we want you to justify and understand that, well, it's 2 because these are the requirements of the application. And that's how they map to the 2 that I have. Right? So we want you to understand why or why not. We want you to understand, again, what the requirements are, which I just mentioned, and how is there redundancy already in the network. It may not be just redundancy of more boxes or more links, but you may go through different modules to get to different places. You may have a recovery state that is already addressing the requirements. It's already going to be beneficial to the network. So, again, you need to understand what you have before you can start saying, well, I need more links, or I need to add another layer, or I need to add another module before I get it to the right place. Around with resiliency, right, we always talk about not just redundancy. And many times when we talk about redundancy, it's about maybe parallel links, same cost. So I'm using both links, for example. When we talk about convergence, what that means is that I need to react and usually find a different path. So now we're not talking about equal cost, maybe we're talking about unequal cost. Right? We have a primary link, we have a backup link, we need to recover, we need to converge, right? So the motivation for doing fast convergence is very, very easy, right? We have applications in our networks that we need them to converge fast. And fast is, of course, relative depending on what application we have. So I mentioned before, email is not even here. Who cares? It can converge in 5 minutes. But if I have voice or video or some other signaling stuff, maybe I want it to converge faster. And so that means that I have to go do things, configure detection, configure reaction, configure other things, so that we actually achieve whatever the motivation is for fast convergence. So when we talk about this, right, and we talk about, pretty much the example that we were talking about before. We have 2 links between A and D. How do we increase the resiliency, right? Do we add another link? Do we do things like configure fast hellos or BFD so that I detect the failure faster and can take action faster? Because, of course, adding another link doesn't mean that the traffic that I'm sending on the bad link works, right? It just means that I have another link for when after I detect the failure. Do I configure LFAs or feasible successors on the links to make sure that when one fails, I have a backup ready, right, for the unequal cost case, which is not apparent if I just add parallel links? Or do I do things like changing the flooding timers? So all these answers may have some base in the requirements that I want to address. But the important thing is for you to understand why, right? So this is not actually a question, but this is just some things to think about, right? Do I add another one? Are these going to be equal cost? Or are they going to be unequal cost? How do I take advantage of the fact that they're unequal cost, LFA, feasible successors, things like that. I always like this graph that talks about the cost and complexity of a solution. And in this scale, we have loss, right? And there are combinations of approaches that I can put in my network that hopefully will keep me somewhere in the middle here. That is not too complex, but that it reduces the loss enough so that I can actually have a solution. Right? I don't necessarily always need to go re-engineer my network or change the operation of the routing protocols to get to the place where I want to be. And I also don't want to go all the way to the extreme of configuring every available knob in the world to get my network to converge faster. Because many times I don't need all the available knobs. I just need some to get to a specific place that I want to get to. So this is just a sort of a reminder that you don't want to apply everything, right? That you want to find yourself in that range that addresses all the requirements and that makes your design simple and resilient and scalable and all the other things that we've talked about. Any questions? What time is the break? Do you know?
After this slide.
After this slide?
After these last slides, yeah.
Oh, after the last slide. So don't go. Yeah.
No, not the last slide.
Okay. So it says here, we're faced with a problem of what type of core we're going to replace technology, right? So it means that we need to rework our core for whatever reason. So what type of core we're gonna look and put in here. So in general, this is a high overview of 4 different options that are out there. So the 4 options are a single plane core option, right? Many networks are built this way. You have one single plane in your network. This is nice. The design is usually maybe a circle with cut-throughs so that I can get some of my traffic to the places where I want to get it across the ring. It is not a ring, so having a partial mesh gives me a little bit more better resiliency, faster convergence, things like that. Again, I have resiliency because of the backup links, and because of the partial mesh, I can do that end-to-end service planning because it's not just a ring, right? It gives me a little bit more flexibility. Some of the negative aspects of a design like this is that this highly technical concept of spaghetti cores, which basically means that you have these 4 things, and now you have a bunch of links across, which looks like a plate of spaghetti, right? And so it can now make it complex to handle the metrics on the link so that your flows go in the right directions. Because now you have maybe a lot more redundancy in the middle than you actually need or want. And you don't want to get to the extreme of having a full mesh of everything in there. Another option is something like this, where we have a core, and instead of having it ourselves, we actually went to an L3 VPN provider. So this looks kind of nice from the edge point of view, because everything in the middle is, of course, handled by the provider that we have there. So there's some nice things, like usually the provider is going to offer SLAs and is going to guarantee you traffic and other things like that you don't have to worry about. That lowers your cost. So this may be an option, right, if you want to go lower your business expenses, because you don't have to go get the links, you don't have to go get additional routers, you don't worry about many things. You just call your provider and say, hey, now I need to connect this guy to that guy over there. And they do an LSP, and that's it. However, there are minimal controls, right? You can tell them you want traffic from here to there, but you can't really engineer the traffic from here to there. You assume that they have an LSP from here to there, but that LSP may go around the world 3 times and then goes to the destination. Right? So there's a lot less control over the things that you may want over, say, the direct link in this case, right? So there are some good and bad things in there. It ties, right, your business performance, again, to the performance of the provider itself, not necessarily the performance that you need or want. So there's some indirect costs there. We see providers, banks, all types of businesses do dual plane cores, where instead of just having one plane, you have two. Instead of having one domain, right, of failure, you have 2 in here. So the idea here is that you can get traffic and you put it on the red or on the blue core and transport it across. This has independent failure domains, right? So it's a nice thing. If one fails, the other one probably keeps on working. So we've seen many people do things like this. Resilience is important. Minimum overlap of the failure domains, right? Because they're independent planes. support end-to-end services, so it's easier for me to now say, well, I'm going to put it here because the red gives me specific quality of service or whatever around, where the black gives me a different traffic profile. So I can choose where and how to implement or deploy my services across my network. I can also, of course, say, well, I have a service that needs a lot of redundancy, so I'm going to connect it to both planes in my network. Of course, there's maybe complexity in management. There's the opportunity of double failures, of course, that may impact both. If I'm not careful and I have my fiber coming to both boxes from the same conduit and I break that, that's it, right? Then it goes away. And of course, there's the cost of equipment. I need double the equipment. So I need to worry about things like that. And then there's the case of the multi-planar core, which is the same as the dual core, except that this one has links between the planes, right? So in the dual core, I have two parallel planes. I send the packets on one side. They end up in the red side on the other end. Here, I may have links between them. So that gives me a little bit more redundancy and resiliency. If I'm in the middle of my network and the red failed, I can go to the blue in the middle. I don't have to keep on the red all the way to the end. So this is, of course, a lot more flexible, right? There's those meet points. I still can do that end-to-end service implementation. Some go on the red mostly, some go on the blue mostly, some can load share. But it doesn't give me that true separation of domains because now they're connected together, right? So I can do some things at the logical level to separate the failure domains, but it's not a truly full physical separated set of planes, right, as the dual plane case. So the question, of course, is which one are you going to choose? And the answer is obviously very simple. Well, the one that satisfies the business and application requirements that I'm looking at. And so you can go look at those things, right, and look and consider, as we talked about, the costs, what are the applications, what am I trying to do, what